The question we are solving now belongs to test series 6. It is of network theory subject. In specific, it belongs to DC network solution methodology. As per the question, there is a DC network given as shown in the figure. It contains a 10 volts voltage source connected in series with a 10 ohm resistor. This combination is connected in parallel with a 1 ohm resistor. The drop across the 1 ohm resistor is measured as V1. There is a current source which is dependent on this potential V1 is connected in parallel with the 1 ohm resistor. The current of the dependent current source is V1. There are two output terminals A and B which are taken from across the current source. We need to find the Norton's equivalent of the circuit as seen from terminals A and B. From the circuit we see that the given circuit contains both independent and dependent sources. From this we can say that Norton's current is equal to the short circuit current flowing between terminals A and B, and Norton's resistance is equal to the open circuit voltage between the terminals A and B and divided by short circuit current flowing between the terminals A and B. So we see that for finding the Norton's equivalent circuit, which contains a current source of current IN in parallel with a resistor of resistance RN, we need to find out ISHAB and VOCAB. Once we find these two quantities, we can find IN and RN easily. First, let us find out VOCAB. For finding the open circuit voltage, by drawing the equivalent circuit of the given circuit, we get that the circuit will look more or less similar to the original circuit. And the drop across the 1 ohm resistor is V1. Hence, let us assume that the potential at the node marked is V1. By performing nodal analysis to the circuit, we see that we can get the equation as V1 minus 10 divided by 10, that is the current flowing through the 10 ohm resistor, plus V1 by 1, that is the current flowing through the 1 ohm resistor, minus V1 is equal to 0. Upon simplifying this, we see that V1 is equal to 10 volts, but VOCAB, that is open circuit voltage between terminals A and B, is equal to V1 is equal to 10 volts. Similarly, let's find out the short circuit current flowing between the terminals A and B. For finding the short circuit current, we can draw the equivalent circuit as shown, but during the same, we need to short the terminals A and B as shown in the figure. So now we need to find the short circuit current that is flowing between the terminals A and B as shown. So because of the reason that the terminals are shorted, the 1 ohm resistor gets shorted. Hence V1 is equal to the 0 volts, and because of which the current of the current source, that is ID, is equal to V1 is equal to 0 ampere. From this we can say that the short circuit current ISHAB is equal to 10 divided by 10, that is equal to 1 ampere. So from the quantities that we got, we see that Norton's current IN is equal to 1 ampere and Norton's resistance RN is equal to VOCAB, that is 10 volts, divided by ISHAB, that is 1 ampere. So from this we can say that Rn is equal to 10 by 1, that is 10 ohms. From this we see that the Norton's equivalent circuit is a 1 ampere current source which has a 10 ohm resistor connected in parallel to the same. From this we see that the correct option which represents the Norton's equivalent of the given circuit is A.